Hi, I'm Yvette Lamar, Director of IBM Z Influencer Ecosystems at IBM, and with me is Stacey Miller, Product Marketing Manager at SUSE. Stacey is my partner in crime as we are co-marketing chairs of the Open Mainframe project. We are super excited to be here today to talk to you about 5 amazing women in technology, our Mainframe Mavens. I am sure you've heard about Ada Lovelace, who created the first computer program, Grace Hopper for inventing computing methods and devices like the compiler, and the Hidden Figures star computer program, Dorothy Vaughan. All were incredibly talented women who are lauded as pioneers in the tech industry. But today, we are going to broaden the aperture card and highlight 5 women who have been instrumental in mainframe technology advances. From the very start of the data center to on the way to quantum computing, these women are at the core of IBM's capabilities and are to this day continuously innovating around data, AI, and security, all to make the impossible possible. So just what exactly makes someone a Maven? I was curious about this because I like the word, but I thought I'd check it out. And according to definitions.net, the word Maven comes from Hebrew via Yiddish, and it means one who understands based on an accumulation of knowledge. A Maven is a trusted expert in a particular field who seeks to pass knowledge on to others, or actually more simply put, someone who is fabulously skilled in any field. So all of our Mavens are quite fabulous, so let's get to know them. Stacey, over to you to get us started.
Thanks, Yvette. Like Yvette said, my name is Stacey Miller, and I'm one of the product marketing managers here at SUSE. The first Maven I want to talk about is Jeanne Salmon. She was a computer scientist. Now, before she became a computer scientist, obviously she was a child, and she was born in New York in 1928. 1928, imagine that. She became interested in the maths, as she called them, at the very young age of 7. And in fact, she famously once told somebody, when I started the first grade, I immediately decided I liked the number stuff. That was not me in grade school. Just putting it out there. So she graduated through the various elements of the U.S. education system, but not without challenges. For instance, the first high school that she wanted to go to, the Bronx High School of Science, she couldn't get into because it was an all-boys high school. And when she did graduate from college, she was denied a teaching position because she didn't have the right requisite history class. Who needs a history class for math? So she finally said, forget this stuff. I'm going to join Metropolitan Life as an actuary. And she actually chose an actuary because that was one of the few jobs a woman can get. And yes, there was a woman's only section of the newspaper. She eventually joined a company called Sperry Gyroscope in the 1950s. And later in 1955, Sperry and Remington Rand merged into Sperry Rand, where Jeanne Salmon met with Grace Hopper, and they began work on the UNIVAC. Salmon left Sperry in 1958 to focus more on computers and joined Sylvania in 1959, where her and her team designed the influential COBOL language in an attempt to create a more portable data language, a more portable processing programming language. In 1961, Salmon joined IBM, where she developed Formac, a Fortran-based mathematics language. Salmon has been recognized by ACM's Lovelace Award in 1989. In 1987, she received the SIG Plan Distinguished Service Award. And in 2009, she received the IEEE Computer Science Computer Pioneer Award. Salmon was very foreseeing when she said, I won't be alive to see it, but there will be enormous advances in the role of robotics. Wow. Salmon died on May 20th, 2017. Our second Maven is Mary Keller. She was born in 1913, and she's really fascinating to me because she was actually an American Roman Catholic religious sister. She entered the Sisters of Charity of the Blessed Virgin Mary in 1932 and took her vows in 1940. In 1958, she started the National Science Foundation workshop in the computer science department at Dartmouth College, which really was an all-male school. She completed both her BS in mathematics and her MS in mathematics and physics in 1953 from DePaul University in Chicago. Keller finally earned her PhD from the University of Wisconsin-Madison in 1965. Keller was most known where she teamed up with two other scientists to develop BASIC. She went on to develop a computer science department at a Catholic college for women called Clark College. And for 20 years, she chairs that department. And she was really a huge advocate for women. And she was somebody who would encourage women to bring their children into school so they could learn computer science. She is known as one of the most famous women in technology for being the first woman to receive a PhD in computer science. And Clark University has established the Mary Keller Computer Science Scholarship in her honor. Mary Keller recognized the explosion of data in one of her famous quotes, where she said, "We're having an information explosion, among others, and it's certainly obvious that information is of no use unless it is available." Mary Keller died in 1985. Yvette?
Okay, our next Maven. It's so inspiring to see the mentorship and encouragement of women in tech from Sister Mary. Just so cool. Now we shift to our next Maven. And while not directly impacting the mainframe, her inventions help us access the mainframe through wireless communications. We've heard about the hidden figure of Dorothy Vaughan and how her critical support of the Apollo mission. So now we go to the hugely public figure of Heidi Lamar, an amazing woman inventor whose technical capabilities were also hidden, but in plain sight. Heidi Lamar was born Hedwig Eva Maria Kiesler, and she was interested in acting at an early age, but she also had the support of her father, who inspired her to look at the world with open eyes. From an article on womenshistory.org, her father actually would often take her for long walks where he would discuss the inner workings of different machines, like the printing press or streetcars. These conversations guided Heidi's thinking, and at only 5 years old, she could be found taking apart and reassembling her music box to understand how the machine operated. On the opposite side, Heidi's mother was a concert pianist and introduced her to the arts. So she had ballet, piano, and machine operating lessons from a young age. She did not grow up in the easiest of times. She was born into a Jewish family in Austria in 1914 on the cusp of World War I. Add on to that, at 18, she married an arms dealer, which had close ties to the Nazis. So in 1937, at only 23, she fled to America to escape the Nazis and her ex-husband. Now, she did become a movie siren in the golden era of Hollywood during World War II, and alas, she still had no formal STEM training. But no formal STEM training didn't stop her from learning, exploring, and inventing. She had great mentors and allies, and it started with her father, and then while she was working at Metro-Goldwyn-Mayer, she met Howard Hughes, and they became an item. Now, what interested Heidi was not Hughes's wealth, but his desire for innovation. Hughes helped Heidi to fuel her inner innovator. He took her to his airplane factories, showed her how the planes were built, and introduced her to how the scientists behind the process. Heidi was inspired to innovate because Hughes wanted to create faster planes that could be sold to the US military. So she bought a book of fish and a book of birds and looked at the fastest of each kind. She then combined the fins of the fish and the wings of the fastest bird to sketch a whole new wing design for Hughes's planes, and he loved it. The gears in her inventive mind continued to turn, and although her most significant invention was engineered as the United States geared up to enter World War II. Heidi was the co-inventor of frequency hopping, originally intended for torpedo guidance in an effort to defeat the Nazis by preventing them from decoding submarine messages. This spread spectrum communications led to modern technology like Wi-Fi, Bluetooth, and GPS. Heidi also became the first woman to receive the Invention Convention's Bulby-Nass Spirit of Achievement Award. It's like the Oscar for inventors. Heidi passed in the year 2000, but her quote is quite relevant even today. The world isn't getting any easier. With all these new inventions, I believe that people are hurried more and pushed more. The hurried way is not the right way. You need time for everything. Time to work, time to play, time to rest. Wise words from an amazing woman. And speaking of wise and fabulously skilled women, let me introduce you to Donna Dillenberger. Donna has had a distinguished career at IBM and is currently serving as IBM Fellow at the company's Research Center in Yorktown Heights. And just so you know, an IBM Fellow is the highest technical of honor at IBM. It's a huge deal. Donna focuses in on machine learning, counterfeit detection, cloud security and availability, and enterprise systems. In the past, she has worked on machine learning models for the financial, insurance, retail, and healthcare industries, and designed new features for system scalability and availability. She is the author of numerous research publications and holds multiple patents, becoming a master inventor at IBM. We are so lucky as we get to hear directly from Donna on her thoughts about IBM Z. Over to Donna.
Hi, I'm Donna Dillenberger. I am an IBM Fellow at IBM Research. And let's see, background. I majored in math and computer science, and when I was a junior in college, IBM came to recruit me, and they said that if I joined IBM, they would pay for my graduate school tuition and books, and also give me a salary. So I joined IBM, and my first job was future hardware simulation, and I really enjoyed that. And I went to graduate school at Columbia University at the same time, and I really liked doing it. I really like doing both. So my day job at IBM, I was implementing features that, my graduate classes was explaining to me the theory about, compilers, computer architecture, operating systems, cryptography, networking. And so the two meshed very well. When I finished graduate school, my professor invited me to come back to Columbia and become a professor. And so I was an adjunct professor at Columbia teaching advanced computer design. I did this at the same time I worked at IBM. IBM lets you just do academic things at the same time. They like that type of academic relationship. Right now, I'm the CTO of Hybrid Cloud Systems Research. And for Z, that means thinking of new features that should go into Z. And there's a whole group of us that does that. We have a whole group at Research working with the Z development team and global services and data and AI. And new things we're working on is AI acceleration in Z. How could we embed Z into transactions for real-time insights? Working with the development team on ZOS container extensions so that you could run a Linux application as part of an address space in ZOS, and all that helps with application modernization, and also it expands the ecosystem of Z. And so how do I think about like future capabilities that should go into Z? First of all, I read the news, and I think about the problems that are occurring in the news. Could technology help? So we've all read about like databases in the clouds getting hacked. Azure databases, Target getting hacked, and that makes me think. Okay, well, what could we provide in Z that would make us more secure? That could protect the user's identity and privacy, and so that's where secure Kubernetes comes from, our signing services, quantum safe crypto. And then, the other things that we read about in the news is this whole digital currency, cryptocurrency trend, right? It's not going to go away, right? Because even beyond Bitcoin, central governments in the world are all thinking about digital assets as a currency. So how in Z could we be like the next platform for that? So that's just a small sample of some of the things that we're looking at. So thanks for the opportunity to talk with you. Bye.
Okay. Oh, I'm such a huge fan of Donna's. He is just an amazing inventor, scientist. And so it's an honor to have her here. I love her quote that we have on the chart here about open source communities. There's nothing that sharpens minds like other minds. So super excited about having Donna and you all be able to hear Donna speak. Our next up, to finish our look at Mainframe Mavens, we have Anna Mckee. Anna has just started her career in enterprise computing, but is already blazing a trail as the first female winner of the Master the Mainframe contest, as well as a repeat winner. She is an avid supporter of women in STEM, and just what a great role model for young women thinking about a career in tech. She currently works at IBM as a DB2 for ZOS systems programmer. But she herself even struggled with her career path and what was her true calling. And through a push from her mother, her biggest inspiration, who is also a techie, she gained the courage to go back home from her sophomore year of college to figure out her passion and enrolled in a coding course at a local junior college. And the rest is history. So let's hear her story.
Hi everyone, my name is Anna Mckee and I am a DB2 for ZOS systems programmer at IBM. I graduated from the University of North Texas a couple years ago with a Bachelor's of Science in Business Computer Information Systems and a Bachelor's of Business Administration in Decision Sciences. During my time at UNT, I was the first woman to win IBM's Master the Mainframe competition in 2017 and was a back-to-back winner for the 2017 and 2018 competition. After my success with Master the Mainframe, I chose to start my mainframe career with IBM. At IBM, I am primarily a DB2 for ZOS systems programmer where I install, configure, customize, and maintain DB2 subsystems and provide assistance to independent software vendors. I am also a systems programmer for WebSphere application server, installation manager, and every so now and then COS. Even though I am semi-new to the mainframe realm, I've noticed that not a lot of technologies can say that they've been around for 60, 70 years. IBM Z has morphed over the decades, and I believe that it's one of the most sophisticated and diverse technologies out there. It's not only the security, scalability, and zero downtime that has kept it around for so long. It is its adaptability to the needs of the world. We live in a digital society where we need to process trillions of transactions a day. We need to keep our data safe and secure, and we need to have our systems be online 24/7. And mainframes can offer that and so much more. It's definitely true when they say IBM Z runs the world. And I am very excited to be a part of that future, and I can't wait to see what's in store for us. Thank you very much.
Anna for sure is going to have a long and illustrious career. I can't wait to see what she does next. Her favorite quote is no surprise. Be fearless in the pursuit of what sets your soul on fire. Words to live by. Stacey, back to you.
Thanks, Yvette. So inspiring. And we've had there's tons of women out there in STEM that we could have chosen from, but these are just 5 of the ones that we picked for this presentation. But in summary, we talked about some of these amazing women, and there are so many out there. So what are some of the traits that made them so amazing or are making them so amazing? Well, they're all resilient. They all face challenges, from not being able to go to the right high school to being shut out of different jobs. But they knew what they wanted, they knew what they liked, and they were able to find ways to build doors and walls that they faced. They were able to break down those barriers. They also had a drive to mentor. They recognized that they may be the first, but they're not going to be the last. So women like myself, like Yvette, like Anna, we're standing on the shoulders of Mary Keller and Jeanne Salmon. We wouldn't be here without them. And finally, they were curious. They had a passion for something and they went after it. They didn't ask the question, what if I can't? They changed it into a what if I can, or what if I had to? What if I had to make myself happy? So I'll leave you with that. If you have a passion out there, if you're a woman in STEM, ask yourself, what if you can? Ask yourself, what if you have to? Because you really do. And don't forget, you might be the first of doing something, but you're not going to be the last. Thanks for listening to us. We really enjoyed researching these women, and we want to thank you.
Yes, thank you so much. It was really a wonderful opportunity to read and to talk with so many amazing women. And I get to work with an amazing woman, Stacey. So thank you, everybody.